understand properties of transpose, you should first know how to take a transpose of a matrix. Once you get to know how to take transpose, it's time to learn properties of transpose. The first property is A transpose of transpose is equals to A. Means taking 2 times transpose of matrix gives us the original matrix. Look at this example. Taking transpose of this matrix, rows changes into columns and gives us this. By taking second transpose, again rows changes into columns and converts it into the original matrix. Taking second transpose is just like undo the first transpose. So this is the first property. The next is A plus B whole transpose is equals to A transpose plus B transpose. Means transpose of addition of two matrices is equal to the addition of individual transposed matrices. For instance, these are two matrices and we have to check for this property. Let's solve the left hand side, which is A plus B whole transpose. So A plus B whole transpose is equal to this. By adding these two, we get this matrix. Now by applying transpose, we get this result. For right hand side, first we take transpose of individual matrices and then we add them and get this. These both are same, so this property is true. The next property is for subtraction and is same as that property of addition. A minus B whole transpose is equals to A transpose minus B transpose. Means transpose of subtraction of two matrices is equal to the subtraction of individual transposed matrices. I let it up to you to check for this property by the same method as we did for the previous property of addition. The next property is A into B whole transpose is equals to B transpose into A transpose. Let's prove it by an example. This is a matrix A with order of 2 by 2 and this is a matrix B with the order of 2 by 3. If you don't know how to multiply two matrices, then I will suggest you to watch a detailed video about the matrix multiplication available in this playlist. So, the multiplication of these two matrices is possible because the number of columns of the matrix A is equal to the number of the rows of the matrix B. Let's do the left hand side first, which we write in this way. First we have to multiply and then we have to take its transpose. So, this is how two matrices multiplied and we get 2, 5, 2 in a row 1, 1, 6, 8 in a row 2. Now let's take its transpose. Rows will be changed into columns and it will be 2, 5, 2 in a column 1, 1, 6, 8 in a column 2. Its order becomes 3 by 2. Now come to the right hand side, which we will write as this. First, take the transpose of the individual matrices and then multiply them. Here you should notice an important point that matrix B comes first on the right hand side of this property, while in the previous properties of addition and subtraction, both the sequence of matrices on both sides were same. So why this happens? Well, after taking transpose, their orders definitely change, but because we already switched the places of matrices, like B comes first and then A comes, the number of columns of first matrix is equal to the number of the rows of the second matrix, which makes their multiplication possible. That's why this property is not like A into B whole transpose is equals to A transpose into B transpose. Now by just perform multiplication, we get the same matrix as it is on the left hand side. Hence, the property is true. Same is for the case of three matrices. A into B into C whole transpose is equals to C transpose into B transpose into A transpose. This is the fifth property. You can prove it by yourself easily as we just did for two matrices. The last property says that K into A whole transpose is equals to K into A transpose. Here K is a constant number, not a matrix. Let's have an example. Matrix A is equals to 1, 0, 2, 0 and K is equals to 2. The left hand side says 2 into matrix whole transpose. Just multiply 2 with every element we get 2040, and after taking transpose it becomes this. The right hand side is equals to 2 into A transpose. Here the only difference is that we will take transpose first and then we will multiply by constant 2. So transpose is 1200. In the next step we get 2400 as same as to the left hand side. Hence the property is proved. If you like the video, please like and subscribe.